Let's look at the last example here. Example 7, it says finding the marginal profit. A fast food restaurant has determined that the monthly demand for its hamburgers is given by P equals 60,000 minus X all over 20,000. And the cost of producing X hamburgers is given by C of X equals 500 plus 0.56X. Find the profit function for the company and determine the profit for the production of 10,000 burgers. Well, to find the profit function is always equal to the revenue function minus the cost function. We have the cost function. That's given to us. No problem there. But we need to find the revenue function. How do we find the revenue function? Well, to find the revenue function, you need to do X times your price demand function. In this case, it would be X times 60,000 minus X all over 20,000. Okay? So go ahead and distribute that X through. That would be 60,000 X minus X squared all over 20,000. That's me distributing the X to both terms here. I'm going to separate and simplify this though. This is the same thing as, 60,000 X over 20,000 minus 1 over 20,000 times X squared. That's 60,000 over 20,000. That's just going to simply turn into a 3. So what I really have is my revenue function, R of X, is equal to, writing it in descending order, negative 1 over 20,000, X squared, and then it would be plus 3X. That's my actual revenue function here. Okay? I have my revenue function. Now what do? Well, I need to find that cost function. The profit function. Again, how do I find the profit function? To find the profit function, I do revenue minus cost. Well, we have revenue. That's negative 1 over 20,000 times X squared plus 3X. And now I'm going to subtract off my cost function, that cost function being 500 plus 0.56X. Go ahead and distribute the negative here. That would be negative 1 over 20,000 X squared plus 3X minus 500 minus 0.56X. We can clean that up. Let's write it in descending order. Again, this is negative 1 over 20,000 X squared. I'm going to combine the 3X minus 0.56X. That would be plus 2.44X. And then I still have the minus 500. So that is my profit function right there. Now it wants to know what's the profit when X equals 10,000. So at 10,000, let's just plug that in. We would have negative 1 over 20,000 times 10,000 squared plus 2.44 times 10,000 minus 500. Of course, I could have used the table feature on this as well if I wanted, by the way. Plugging that into your calculator, let's see what the actual profit is. I'm getting a profit of $18,900. So if this company sells 10,000 hamburgers, it will make a profit of $18,900. It says find the marginal profit for the company and determine the marginal profit for the production of 10,000 hamburgers. So again, we know our profit function is negative 1 over 20,000 X squared plus 2.44X minus 500. If I want to find the derivative of that, the marginal profit function, that'd be the constant, which is negative 1 over 20,000, times the derivative of X squared, which is 2X, plus 2.44 times the derivative of X is 1, minus the derivative of 500, a constant, is 0. What am I getting here? I'm getting negative 1 over 10,000 X plus 2.44. That is my marginal profit function. Now what did it want? Well, it wanted the marginal profit for 10,000 units. So what do? Plug in 10,000. That would be P prime of 10,000 which is negative 1 over 10,000 times 10,000 plus 2.44. I know these are nasty numbers. Remember, real world is real ugly numbers. That's perfectly fine. And what are you ending up with? I'm getting the number 1.44. But remember, profit, marginal profit is dP dx. Profit is measured in dollars. X is measured in units. So when we see that 1.44, our marginal profit would be $1.44 per unit, or in this case, per burger. Sorry, I put that in the wrong blank. We have the marginal profit function. That's given to us right there. The marginal profit is $1.44 per unit or per burger. So what does that mean? That does not mean that this person is only making a $1.44 profit if they sell 10,000 burgers. That means the profit from the 10,000th burger to the 10,001st burger. The profit off of the sale of that one single next burger should be $1.44. Part C says compare the marginal profit when 10,000 burgers are produced with the actual increase in profit from 10,000 to 10,001 burgers. So again, this $1.44 per unit or per burger increase is our estimation of the profit that we make from that 10,001st burger. How do we find out what we actually made? Well, we need to do the profit of 10,001 burgers minus the profit of 10,000 burgers. I'm going to go ahead and use the table because I'm done with this. Our profit function, go back to the original profit function, which was negative 1 over 20,000 x squared plus 2.44x minus 500. Okay, I'm going to plug in the number 10,001. I'm going to plug in the number 10,000. Let's see what we get here. I hit table. I hit clear. I type in my function. I'm going to use n over d for the fraction. Negative 1 over, I hit down, I hit 20,000. I hit the right arrow to get out of the bottom of the fraction. I'm going to hit x squared plus 2.44x minus 500. I hit enter, enter. I make sure ask x is selected, hit enter. Now I type in the numbers 10,001, hit enter. I'm getting 18,901.44 rounded to the nearest cent. And then I hit 10,000, enter, and then I'm getting $18,900. So what was the actual change in profit? Well, that would be $18,901.44 minus that $18,900, which gives me a profit of $1.44. What does that mean? That means our marginal profit, our estimation as to the rate of change, what our profit should be for the sale of that next unit, was exactly the same as the actual sale for the next unit. Again, this is just because we're using the estimation from the 10,000th unit to the 10,001st unit, it's very accurate. If we said what's the estimation from the 10,000th unit to the 20,000th unit, it would not be near as accurate. But there it is.